Hi, this is Zachary McNulty, and this is my video on my mini project about rectangles and approximating pi. So this is a drawing that I made, getting kind of the idea of what I'm looking for here in my program. This is the unit circle of one quadrant, quadrant 1 of it. And the idea is, how am I going to approximate the value, the area of this quadrant of the unit circle that I'm tracing out with the mouse? And the way that we're going to do it is by estimating it with the value of the areas of these two rectangles, or n amount of rectangles, as many rectangles as the user wants to use. And the way that we do that, and I drew a little picture over here, is the base times the height equals the area. In this case, x is going to equal the base and y is going to equal the height. So now I have to define those figures. X is pretty easy. The way I'm going to do it is by using the midpoint of any number of the rectangles. So if I'm doing two rectangles, I'm going to go to the midpoint of the first rectangle, find where y is, and that's going to be my value for y, and I'll go over that in a second. Go to my second rectangle, and I'm going to find the midpoint of that second rectangle, go up there on the y scale, and find where my value of y is. And then I'm going to take the two values of these areas, and I'm going to add them together, and that is my approximation of 1/4 of pi, which I also drew up here for a little reference. So how do I find y? I use this formula here, which helps me find any value on any point on the unit circle. X squared plus y squared equals r squared. Now I know what r is. It's 1 because it's a unit circle. So the radius is always 1 on a unit circle. So I made this formula into this formula, which is y equals r squared, which we know is 1, minus x squared. We know what x squared is because the user is going to input how many rectangles they're going to use, and I'm going to then, with my program, find the midpoints and find the value for x. This formula here is to find the value of y. So square root of 1 minus x squared, and then using that, inputting it into this function, h times b equals the area, adding up those areas, and so I'll show you the code. So what we have here is the code for my program. Import math, because I'm using the square root function. Defining my project title, as this function uses rectangles, filling the inside of quadrant 1 by following the arc of the unit circle to approximate pi, or rather 1/4 of pi, but later adding or multiplying that to equal pi. I've set n as the input from the user. How many rectangles would you like to make? And that again is how many of these am I going to be making? Not just 2, but any number. I assign that the value n, and then my next line is another input. What margin of error percentage would you like to stop at? And notice I said percentage, so they're going to be entering this as a percent. I later change that to be a decimal place, but then give it back to them as a percent. Or enter 1, 2, 3 and skip this option, and I'll go over that later. So I assign that to the value error, and then the next couple, I have area I define as 0, x2 is equals 0, and y equals 0. And I set those all up so that the program knows that later it already knows what these variables are. I also define x1 up here as 1/n. So if I had given, 2 rectangles, like in the example here, that would be 1/2. And I haven't defined x2 yet because that's something that's going to be looping in my for loop here. For I in range 0, so I'm starting at the number 0, to n plus 1, because the range stops 1 before the actual ending number. And the formula for x2 is a sum accumulator. It's going to be x2 plus itself, which the first time through is going to be 0, plus x1, which is always going to be 1/n, whatever number n is. So that's my definition there. But if it's the first time I go through this function, if I equals to 0, x2 is going to equal x2 minus an n. And that's because the first time I go through this loop, I am saying x1 is equal to, in this example of 2, 1/2. And x2 is going to equal 1/2 plus 1/4. And that's so that I can go from 1/2 plus 1/4 to get to the next loop. But the first time, I don't need that extra quarter. I just need to be exactly right there. So the first time through, I subtract an nth off. Every other time it skips that part. So here y, which we already defined as 0, y equals the square root of absolute value of 1 minus x2, my variable, squared, which looks a lot like this, but not as cool. So I also define area as area equals area plus x1 times y, which is the formula before of x times y equals area, h times b equals the area. It's the area of our rectangle. Again, another sum accumulator. I have area equals area plus the area of the rectangle we are figuring out this time through the for loop. We'll go over the last part of this in a second. So I'm just going to give you an example of we're going through our for loop. The first time through, let's say in this example, n equals 4. So we're going to come through x2 equals x1, which we know is a fourth in this example, plus x2, which we have as 0. And if we're going through the first time, so n equals 0, or I equals 0, x2 equals x2 minus a half. So now I am down to an 8. And that puts us right here, if this was 4 rectangles. It put us right there. It's halfway through the half rectangle. And then I'm going to calculate my y, and then I'm going to add area, which is 0 in the first example, 0 plus the area of my rectangle. Then it's going to go through the second time. Okay, x2 equals x1, which is a fourth, plus x2, which last time was an eighth. So if this is true, which it isn't this time, so we're going to skip that line, I'm going to define y using the new value for x2 here, and then calculate the area of just that second rectangle. And again, there's 4 in my example I'm giving right here. So it's going to do that for any number of n that we did. And remember this error here, if this is the line for the error. If my margin of error is equal to or is less than or equal to the error that the user submitted, or the user wanted to skip this, and the user did not select to skip this, then I'm going to print this statement here. So I'm stopping the function. You've hit I number of rectangles, which is where we stopped. So it's going to be for I there. I is the fewest number of rectangles, keeping your desired error here. And I'm going to give you an approximation of where that equals, comparison to pi. So I'm multiplying the area that I've calculated here by 4 and rounded it to 5 numbers. All of my numbers here have been rounded. You can see the round there. And then stop the function, break. But let's say the user entered 1, 2, 3, didn't want to see this, didn't care about the percentage of error. They were like, I want to see what the approximation of 25,464 rectangles looks like. Else, the area of your rectangles is, that's just the number right there for the n number of rectangles. That makes your approximation of pi, which is multiplying it by 4, equal to that. And the actual value of pi, just for your reference, is this. And that's about, and I just tell you the margin of error that you are right there too. And so the way I calculated the relative error is the value of pi minus the value of my area times 4, my total area times 4, divided by the value of pi, times 100 to make it a percent. So we're going to try this out with a couple different values. So the first one we're going to do is 2. And we're just going to skip this option for the first couple times through. 1, 2, 3. So that's the area of our total of the rectangles. That makes this times 4 equal to 3.73205, the actual value of pi, and that's the percentage off. So let's try that again with a different value. Oops. 20. Skipping this step. Here's the results, got a little bit closer, a little less percentage of error. And again, with 2,000 this time. Skipping that step. Closer, we're at, hundredths of percent here. And last is going to be 2 million. So 1, 2, 3, 4, 5, 6. Got to think a little bit. It's a lot of thinking to do. There we are. Scroll down a little bit. So that's where we're at. Now let's say we wanted to see how close we can, how many rectangles, what does n equal, the smallest number for n for 0.001% relative error. Well, we'll run the program again, and this time we'll enter it into the other part. Just try this so you can see it a little bit better. How many rectangles would we like to make? We'll just enter a large number. The margin of error, 0.001%. It's thinking. Alright, so that's the number of rectangles. That's the fewest number of rectangles keeping the desired margin of error. And, that's about that value in relation to pi. So that's the example of my program. If you have any questions about the code, please post them. And that's about it. Thanks.